So now we're going to be having a look at sampling. We've actually split the sampling up into two different sections here just to make it more manageable. So, undertaking a census of gathering information about the population gives accurate and complete information. However, it is very costly and a lot of time to carry out, and it's not always possible. For instance, if you're wanting to do a hypothesis test about people in America, you'd have to have everybody in America fill out your questionnaire or your census, and that would take you quite a lot of time to do, a lot of money, and you'd have to chase the people that didn't end up giving in the information. So a sampling of those people is a better and cheaper, quicker and easier way to verify the information as long as it is collected accurately. And we're talking about a number of different sampling methods. In this first sampling section, we're looking at a simple random sample, an unrestricted random sample, and a systematic sample. Now, sampling is very important. The reason why sampling is so important is that it is the basis of our entire hypothesis test. If we do the sampling section of our data collection incorrectly, that can invalidate any results that we find. So it is actually the most important part of statistics. So as I said, we're looking at a simple random, an unrestricted random, and a systematic in this section. So for a simple random sample, we have to list the population in a certain order. That order could be date of birth, alphabetically by surname. If it was employees, it could be through an employee number. Anything that meant that the order in which we were listing our population was not biased. That's the whole reason why we have to put them into a list, to eliminate bias. So you have to specify what order you are putting your population in. You then need to number them from 1 to however many people you have, and that's what we call creating our sampling frame. We then need to use a random number generator, or you could use a random number table, or you could use something as simple as picking numbers out of a hat between 1 and however many people we have. Here I've just put P. And we need to repeat this several times until we have a sample of size n. Now, a very important feature of a simple random sample is that we have to do what is called ignore repeats. And what that means is that if we pick the same number out twice, or if we randomly generate the same number twice, we do not count it twice. Instead, we have to generate an extra number to replace that number that's appeared twice. And that is the difference between the simple random sample and the unrestricted random sample. So, for a simple random sample, if we have 1,934 head teachers and we're wanting to perform a simple random sample of size 100, we would first have to put the head teachers in order. And I'm going to say here by date of birth. Like I said, it can be any order that you wish to put it in as long as it is an unbiased order. So something that isn't subjective. Then we're going to number the teachers from 0001 to 1934. And it's up to you whether you use the 4-digit numbering system because we have 4 digits here, or whether you want to just say 1 to 1934. You'll still get the marks in the exam. Then we're going to use a random number generator. To generate a random number between 0001 and 1934. We're going to repeat this until we have a sample of 100, ignoring repeats. And then you have to have an actioning word, okay? That means that you have to say what you're going to do, okay? So then you have to say, give, let's say it's a questionnaire, to selected teachers. Now it's a good opportunity to pause the video and give the Now You Try a go. So here in the Now You Try, there are 712 employees in a large city centre store. How would you obtain a simple random sample of size 60? So let's say that this time we're going to put employees in alphabetical order . Let's say by surname. Then we're going to number the employees . From 001 to 712. So this time you can see that I've gone from a 3-digit numbering system because 712 only has 3 digits. Again, you could just say 1 to 712, you'd still get the marks. Then use a random number generator to generate a random number between 001 and 712. Then we're going to repeat this until we have a sample of 60 this time. Remember, ignoring repeats, that's very important. And then we're going to give, let's say it's another questionnaire. To the selected employees. So that is a simple random sample, and like I said before, the most important thing there is this ignoring repeats part. The reason why it's very important is because, as I said before, that's the difference between a simple random sample and an unrestricted random sample. So for an unrestricted random sample, this is the same as a simple random sample. However, the restrictions of not allowing repeats is not being used. So we allow the same person to give their opinion or to fill out the survey more than once, so it could be twice or it could be even more than those times. However, that is normally an undesirable quality. So usually if you're wanting to gather a sample of data, a simple random sample is the best way to do it, because with an unrestricted random sample, if you're only having a small sample of people and you have the same person donating their information more than once, that could be swaying the results. So if we had the same situations again, however this time we were performing an unrestricted random sample, like I said before, it has the same steps. So again, we would put the teachers into, let's say, alphabetical order this time. By surname. We would number the teachers from 0001 to 1934. We would use a random number generator to generate a random number between 0001 and 1934. We would repeat until we had a sample of 100. And you don't have to say include repeats, but you can do. And then we would give out our questionnaire to the selected teachers. So as I said before, what order you put the names into to begin with, that doesn't matter, as long as it is some sort of unbiased way of ordering them. And this time it's exactly the same as our simple random sample, except for the fact that this time it is an unrestricted random sample, so we want to include any names or any numbers that come out more than once. Now is a good time to pause the video and give the Now You try a go. Okay, so hopefully you've given the Now You try a go. So this time, because I put the teachers into alphabetical order, I will put the employees into order using their employee number. Okay, so put employees into employee number order. And then we can still number them. The reason why I'm still saying to number the employees is because it's not guaranteed that that the employee numbers would follow a normal numbering system. For instance, they could have letters in them. They could have other characters in them. Oops, sorry, I've put one too many zeros in there now. But they might not necessarily just be like employee number 1. They could be employee E197. Okay, so that means that we still want to put them into some sort of order so that then we can use a random number generator to generate a random number between 001 to 712 instead of having to try and come up with a random numbering system which will follow the format of the employee's number. That's why we've numbered them again. And as before, we will repeat until we have a sample of 60. And like I said before, you don't have to state include repeats, but if that makes you feel more comfortable that you're getting your point across, this includes repeats. Simple random sample ignores repeats. And then we're going to give out our survey to the selected employees. As I said before, we're going to have a look at a third sampling method now, and this is different from the two that we've already looked at, and this is called a systematic sample. So just to verify before we move on to that, a random sample, what it means by actually being a random sample is that it's a method which is possible to obtain any combination of individuals from the entire population. So when in an exam question, when we're doing a hypothesis question, quite a lot of times it says random sample. And the reason why this is important is because of this reason here. And what this actually means is that any of the samples that you could imagine taking can be taken in a random sample, and any combinations of those samples are also possible. So that means that you could end up with a sample that includes person 1, 2, 3, 4, 5. It's very unlikely, but that could happen, and that's why it's important is that any of the samples that could be created can still be created. Now this is completely different from what we call a representative sample. Now a representative sample is a method that produces a sample that accurately reflects the characteristics of the population. So that means that we are getting a viewpoint for respective characteristics that we think may sway what we're looking at, so that it's not biased. Now, both the sampling methods that we talked about just now, obviously they are both random. Any combinations of samples and any samples made up of individuals are possible. However, they are both not, so they are not representative. It could be random that we end up with a representative sample, but it's not guaranteed. So that needs to be bared in mind when you are performing an analysis. So, like I said, the last one that we're going to look at is the systematic sample. So a systematic sample is also not a representative sampling method. If the population for which the sample is being taken from is ordered by a characteristic, then a systematic sample will ensure that it is represented of a variety within the characteristic. So for instance, if you wanted to take a sample of people and you decided to put them into height order, a systematic sample would give you a few short people, a few medium height people, and a few tall people. But it might not necessarily be representative because you might only have a small number of short people and a small number of tall people, but they might end up with the same representation in your sample. So it might still not be representative. That also means because we cannot end up with 1, 2, 3, 4, 5, as you'll see in a minute when I start talking about how we do the sample, that means that this is also not giving us a random sample. So for a systematic sample, we have to order the population by a required characteristic. We're going to number them as we did with the simple random sample and the unrestricted random sample. However, this time, instead of just using a random number generator, we're going to divide n, which is our population, by n, which is our sample size, And this gives us what we call our sampling interval. Then we're still going to use a random number generator to get what we call our starting point, which is done by randomly generating a number between 1 and whatever we get from doing p divided by our sample size. We're then going to repeat this until we end up with our required sample. So here we have an example. So there are a total of 985 pupils spread across 5 different year groups in Aberdasher's Comprehensive School. I think that's pronounced. How could we obtain a simple random sample of 20 pupils? So because they've emphasised here that it's spread across 5 year groups, we could say that we're going to put them in date of birth order, because it tends to suggest that this 5 different year groups is going to be important. So we're going to order the pupils by their date of birth. We're then going to number the pupils from 001 to 985. And then, just as a little side calculation, if we do 985 divided by our sample size, which is 20, so 985 divided by 20 gives us 49.25. Oops. Now this is something quite important, because usually, if this was maths, then we would round 49.25 down, because obviously we can't randomly generate a number if we've numbered things in integers. We can't generate a random number that is 49.25. So usually we would round that down because it's closer to 49 than it is to 50. However, if we were to do that, then the people at the end of our list would have no chance of being selected. So instead, we are always going to round this value up. So we are going to use a random number generator to randomly generate a number between 001 and 050. And like I said, that's our starting point. And then we're going to go up by 50 each time. So we're then going to select every 50th person after that until we have a sample of 20. And quite an important thing here, because if I was to randomly generate the number 50 to begin with, and if I was to add on 50 each time, then actually by the time I got to the end, I still wouldn't have a sample of 20. So we can add in an extra clause saying if we reach the end of the list, we will circle back to the beginning. And just as we had before, we can give out our questionnaire to the selected pupils. Now is a good time to pause the video and give the Now You try a go. Okay, so hopefully you've given the Now You try a go. So this time we've got 2,700 employees of a distribution company, and their number of years of service for the company is known. So this time it's hinting that that should be what we order them by. And we're trying to describe a way that we perform a systematic sample of 50 employees. So this time we're going to order the employees by length of service. And you could even add a little extra bit saying alphabetically for those with the same length. So just to explain what we were going to do with anybody who has the exact same length of service, because if you have two people who started on the same day. So then we're going to number the employees from 0001 to 2,700. And then our little side bit of working out, 2,700 divided by 50. So 2,700 divided by 50 gives us 54. So this time we don't have to do any rounding. It's just giving us 54. So now we can say that we're going to use a random number generator to randomly generate a number between 0001 and 0054. Then we're going to choose every 54th person after that. And this time, because we didn't have to do any rounding, we don't have to add in that extra aspect of saying that we would go around in a circle if we had got to the end, because this time we've got exactly 54 when we did our division. So the worst case scenario, if we had 54 as our random number generated number at the beginning, then our last number would be 2,700, sorry. So that means that it would fit in exactly, so we don't need to worry about that. So then we would give our questionnaire to selected employees. So something that we haven't talked about in any of these examples is a bit of a contingency. So what I mean by a contingency is what happens if we end up getting a survey back that's incorrectly filled in, or what are we going to do if somebody doesn't fill in the survey and give it back. Now, the best contingency that we can come up with is for any of these examples to just take a slightly larger sample than what we need. So for example here, in our example question with the 985 pupils, we could say that instead of taking a sample of 20, we'll first take a sample of 25 or 30, and then we'll use the first 20 numbers that we pulled out as our actual sample, and the other 5 or 10 can be our backup. Same for the employees, we could first do a sample of 60 or 70, and then we could use those extra 10 or 20 names to be our contingency. And that's quite important when you're getting your sample of people to perform your hypothesis on, that we have a little bit of a contingency for if we don't get any of them back, or we're missing a few of them, or they're filled in incorrectly. So there are more sampling methods, and they will be covered in the Sampling Methods 2 video. Thank you very much for listening.